In this video, we'll generate the binomial series Pascal Triangle Coefficients using COMBINA, Taylor-Maclaurin series sum, and LINEST Polynomial Regression. We begin with the 1 minus x to the power k, where the value of k is from 0 to 4. So data validation, list of items 0 to 4. So here are the values of k. And we use the array formula of the quantity 1 minus x raised to the power k. Enter. And you have the trend line. At k equals 0, our y, or 1 minus x to the power k, is 1. This is the trend line polynomial and our trend line. If it is 1, then our trend line polynomial now is 1 minus x to the power 1, which is 1 minus x, which is also the Pascal triangle coefficient 1, negative 1. If we sign 2, then our Pascal triangle coefficients will be 1 minus 2, 1, which is the trend line and the trend line equation. 1 minus 2x plus x squared. The rest are 0 because these are very small. Next, we use this array formula in the 1 plus x to the k. So 1 array formula of the quantity 1 plus x to the power k raised to the power k. And you have this trend line. And the trend line equation is 1 plus 2x plus x squared. It's different from this. This is 1 minus 2x plus x squared. This one is 1 plus 2x plus x squared. And Pascal triangle coefficients now is 1, 2, 1. Next, we use the Taylor-Maclaurin series sum to generate both. So it is a times x to the power n, where a is c to the power n times COMBINA k minus n plus 1 comma n. And the value of n is from 0 to infinity. So we go with 0 to 8. Now we can use the series sum. So array formula, series sum of the x values raised to the power n, which starts from 0, incremented by 1, and the coefficient will be this range. And the value of c is negative 1 if it is 1 minus x to the power k. It is positive 1 if it is 1 plus x to the power k. So we have data validation, list of items, negative 1 if it is 1 minus x, positive 1 if it is 1 plus x. These are the two values of c, negative 1 for this range and positive 1 for this range. So we complete the coefficients of our formula of the c raised to the power, or c raised to the power n times COMBINA k minus n. So that's k minus n. K minus n plus 1, comma n, comma n. Enter. So this is minus. That's k minus n plus 1. So we have an error. If n is greater than k, this should be 0. To correct this formula, we use the if statement. So if, comma, 0, comma. So if n is greater than k, so if n is greater than k, then 0, Otherwise, calculate. Now it's corrected. So if n is greater than k, it should be 0. So we change that to 3. This is 0 because n is greater than k. Now we can calculate the regression coefficients of this trendline equation. So our trend line now is 1. If it is -1, the red, the, the Taylor-Maclaurin series sum expansion is, is on the blue datasets. If it is +1, the Taylor-Maclaurin series expansion is the same as the green dataset. So the red is on the green datasets. Now we calculate the regression coefficients using LINEST. So to do that, we complete the 1, x matrix, starting with the power transpose 0 to 8. So we have the power and the 1, x matrix using array formula. Array formula of the x values raised to the power 0 to 8. Now that we have the 1, x matrix, we can use LINEST. LINEST data y and data x. And on the Taylor-Maclaurin series sum expansion, LINEST data y and data x. And the 1 plus x to the power k is also data y and data x. Enter. So these are the Pascal Triangle Coefficients, which is also the regression coefficients. In the case of the red or the Taylor-Maclaurin series sum expansion, they are always the same as their expansion coefficients. Now let's compare by changing the values of c. If c is -1, the dataset of the expansion, Taylor-Maclaurin series sum expansion, is the same as the 1 plus x to the power 1 minus x to the power k. And the red line is on the blue datasets. And the regression coefficients are the same. The Pascal triangle coefficients are the same. If c equals +1, the datasets of the Taylor-Maclaurin series expansion is the same as the green, which is 1 plus x to the power k. And the red line is on the green, and the Pascal triangle coefficients of the expansion is the same as the 1 plus x to the power k. So this completes the use of the COMBINA function, Taylor-Maclaurin series sum, LINEST polynomial regression to generate binomial series Pascal triangle coefficients.